Okay, I think we got people. I'll go ahead and jump in. So if you're here, I hope you're interested in Meshtastic. Let me start with a couple questions. Who's seen something about Meshtastic, knows a little bit what you're going to talk here about? Great. How many of you have a Meshtastic node running? Okay, about half the group. Good, good, good. I brought a couple pieces of hardware we'll show you in a second, but this is a good start. Their slide thing is driving me crazy. I've lost my talk. There I am. Okay, good. Up and down will work. There I am. Okay, who am I? I've been around the open source world for a long time. I've been working in the media and entertainment industry for about 30 years. But I like to play with a lot of different stuff in my own spare time, plus in my business stuff. Mostly I've focused on high performance computing, security. That's the stuff all for work. But this stuff, the Meshtastic stuff, has been a lot of fun for my own personal devices. Somebody asked me recently, how did I get involved with Meshtastic? It's because I started with LORA to do device communication, and then I saw the Meshtastic come up and build a community around it, and I went, hey, this is a really cool tool for anybody to start doing wireless radio and start being able to talk to each other. So that's what got me in. I am not a radio expert. I don't have a ham license. So I may say a couple things that are wrong. So far, this talk has not been, no one has crossed me on the talk, so I've gotten away with it so far. But if there is anything that's wrong, let me know. This talk has 3 parts. The first part's sort of motivational, right? I want you to understand why I care about this stuff and why I think it's important for you to care. And then we're going to talk a little bit about Meshtastic in general. And then at the end, I'm going to talk about how you can actually secure your devices and use it in a way that is the most private, and you can make a decision as to why you're choosing to do that and what things you want to protect against. So what do I mean when I say covert regional communications, right? That's a big set of words. First of all, no eavesdropping. Right? You should be able to have you should be able to talk on your network and not have people you don't want listening. Limited geographic area, right? These are regional devices, they're radios. There's a certain number of hops that your radio will talk, so it's going to be limited to a geographical area. It's not going to be the entire world. It's not going to be the whole US, right? There's an additional benefit. Now we're getting down to some more subtler benefits. There's an additional benefit of not being able to locate where your communication is coming from, right? Being able to wander around or have nodes in locations and not be able to track them, right, is a useful feature. And then being pseudo-anonymous, right, pseudo-anonymous, if you can use your name and not have anything else registered to you as a person, you can make up your own name, no one knows who you are, you can change your name at will, right, all those are good features for covert communication. This is some of the politics. Now, I'm politics light. I just want you to look at some of the things that are going on in the world today. I was at the No Kings rally in LA, right? Marching in front of the National Guard. Shouldn't be like that. And this is all current. Right? This is not normal. This is stuff that we do need to think about, that we do need to protect. And if I missed any of your specific causes, it's only because I submitted these slides a couple weeks ago. We are living in a panopticon, whether you know it or not, right? Automatic license plate registration systems. All this data is pulled from the EFF's Atlas of Surveillance. But you can look up your own area and see what kinds of surveillance are out there and what your cities and your police departments and et cetera are doing. But automatic license plate registration systems are all over the place, commercial and governmental, right? And they are sharing the databases so we know where your vehicle is, right? Facial recognition systems. There are networks of these things. Like I said, the cameras and the license plate registrations are all being shared. And then even though they're not supposed to be used for anything outside, in California, they're not supposed to be used for anything outside their own law enforcement and stuff. Homeland Security, for example, is just going in saying we're HSI, and that's a good reason for us to go get stuff. There are drone services. My own city has drones, and they're trying to demonstrate why they have them and how they should be using them to surveil our public. Body cams are common on our police. By the way, when you do get in issues with this, Freedom of Information Acts are really great, and they cause your city a lot of hassle, and I've had fights with my own city where we've had to do these kinds of things. Cell site simulators are all over the place. EFS has a neat tool called Ray Hunter, which basically uses an old wireless hotspot to track whether or not cell site simulators are deployed and then records all the data. So check all this stuff out. Love everything the EFF is doing to support us. But we need to support our communities, right? This is what I care about, why this matters, why this should matter to you. I don't care what community you like, who are you associated with, but you gotta be able to talk to them, right? And our government is shutting down a lot of the ways of doing that, right? So if the infrastructure goes down, you have a way to communicate for emergency services, for those kinds of things. If you have groups where you need to, for example, announce where there might be people rounding up other people and grabbing them off the street, and you want to do that privately, you might be useful to have a radio network and not have something that's trackable, right? If you want to report activities and share intelligence, you need a way to do that. If you need to coordinate group actions, you need a way to do that, right? So communication is critical to all of this. And we need a way to do that without being monitored and without being, and basically privately run. And I'll say I'm an optimist, right? I mean, that's the other part of this, right? We need to do something about this. We need to have hope for the future, right? And to do that, you have to be able to, you have to be able to be optimistic. Now I'm going to put Signal up here. I love Signal. It's a great tool. It works really well. It is easy to use. No disparagement of Signal at all in this stuff. But you got to have a cell phone. You got to pay for an expensive device. You got to pay for a monthly service, right? You got to tie it to a cell phone. You got to tie it to a phone number of some sort, right? All these things are issues with Signal that don't make it nearly as anonymous as an arbitrary radio node. So, motivation. Okay. So for the people, most of the group here already knows what Meshtastic is. For the 25% that didn't raise their hand already, right? If you combine a LORA radio with a microcontroller and some open source software, you get Meshtastic, right? That's it. In front of me, I've got a couple different devices, right? So this is a Heltec V3. It's a $20 device, right? You can buy it off of Amazon, right? This will get you started with Meshtastic today, right? Really easy to use. This is a LilyGo T-Beam. This has a GPS added on to it and then an 18650 cell on the back of it. So again, around a $20 device. And with a battery, with an 18650 cell, you can run it for about a day. Just turn it on and leave it running somewhere. This is a LilyGo T-Deck. So now they've put the whole thing together with a keyboard and a screen and a battery built into one, right? Same basic device underneath, right? But now I have a device that I can carry with me, communicate locally, and not have to have my cell phone with me at all, right? Those other two devices, I needed some way to connect it to it and talk to them, right? That's usually Bluetooth from your cell phone. That means I got to carry my cell phone. I got to turn on my Bluetooth. My Bluetooth is sending its unique ID all the time, right? It's not, you're not as light as you would be with this, right? So a couple different devices to choose from. Meshtastic is the open source software underneath all this. It gives you a bunch of neat capabilities, right? So it's what we call a mesh network. What that means is every node you add to the network will share the traffic with everybody else and allow you to send data further than your radio could do by itself because the mesh cooperates and sends the packets along the way. Instant anonymous join. Buy a node, turn it on, you are on the network, load the software, you're on the network, you're done, right? So you don't have to do anything else, there's no registration, nothing else, right? You should think of it basically as texting. It's a fairly low data rate, but, and there's group chat channels, that's what Meshtastic is doing, but think of it like a texting system. Fairly inexpensive, right? We're talking about $20 for that node, the Heltec node that I just showed you. If you want that, this thing's about $100, right? My roof node, I put a bigger antenna on it and a big battery and a solar panel, and again, about $100 worth of stuff by the time I was done. Not very expensive stuff to deal with. A couple other more esoteric features. MQTT is a messaging system that uses a computer and the internet, right? So if you want to bridge a long distance where you don't have radios, you can basically sign up to use MQTT to forward traffic back and forth using that to cross the gap. It has a software API, so you can have your computer use HTTP to talk to your node and send stuff out over the radio. So now your computer can send stuff or read everything that's going on and process it in a way you think is useful. 915 megahertz, 13 megahertz of bandwidth, unlicensed industrial, scientific, and medical band, low power devices. That basically, for radio guys, that's important. What that means for you as a user is no licensing requirement, no registration requirement. This is stuff that anybody can turn on and fire up and use, right, without, without other needs. You don't need a ham license. You don't need anything else, right? Low power devices. So if you want to get started using Meshtastic, like I said, get a node. A little Heltec one is cheap. You connect it to your PC. You use the web flasher to put the software on it, right? So you'll run a Chrome browser and do it or whatever. And then you use your phone to connect to the node. You're basically up at that point. It is a remarkably easy process to get started, right? So if you want to play with radio and you want to get involved. Now, I've got this thing up and running, and I see 189 nodes right now here, in the area, right? Just to give you a data point. There's probably 300 in the Los Angeles area where I am. I've had a 78 kilometer, most of these, I don't know if I included I did, okay. Urban environment, the single radio will do about 2 to 5 kilometers in an urban environment, right? These are low power devices, they're not gonna go overly far, but you're gonna hit another node who's gonna forward the packet to the next node that's gonna forward to the next node. Yeah, so there's mountain nodes in lots of places that are really useful, and we have some of them in Southern California. The question was, what if I'm up in the mountains somewhere, right? So line of sight helps a hell of a lot. That's the reason I put my node at my roof line so I can get my antenna up above the house and I can extend a little bit in my area. But absolutely, right? There are people on planes that are doing it at altitudes as well. I see those node people registering. Everyone's like, hey, I'm on this flight. I'm doing, I've got my private plane. I'm doing, So up elevation helps. Rural is going to get you more range, right? You're going to have less obstacles in the way, so 15 kilometers-ish. The record's about 1,300 kilometers with a focused antenna in a specific direction. Line of sight's really helpful, right? Look at what's blocking your radio antenna direction, and there's some websites that can help you look at that too. You get to say how many hops. Meshtastic supports up to 7 hops. With 5 hops, I can do about 50 kilometers in either direction around me, so I can get down to, from Los Angeles, I can get down to Fullerton, or I can get up into the Simi Valley pretty easily, which is kind of a nice number, right? I don't need to turn it up larger than that. I did have a radio hit 78 kilometers away from me, where somebody said, I got you direct radio, right, 78 kilometers from my house node. Right, happened to be good conditions. I don't know. I'm not a radio expert. I don't know how the hell that worked, but it did. Other people, of course, would get it from multiple hops. I said this a little bit, 300 nodes in Los Angeles. We also have a Discord channel, which is kind of nice, and there's a thing called the Parrot that will relay your traffic from Meshtastic into the Discord channel, so you can test things and see how far your packet went by seeing which nodes on the Parrot network picked it up. And it's a good community that talks amongst themselves, and they run test days and stuff on Wednesday nights. So we have a good SoCal community. I don't know what it is up here, but again, pretty good number of nodes. So let's move on a little bit more specific, right? So when you start up, long fast is typically the default channel. That's an unencrypted channel. And long fast represents how the radio is configured. There are lots of ways to configure the radio that can give you more data rate versus shorter range versus reliability, right? So there's some trade-offs you can do there. You can configure it in different ways. But long fast is what most people are using most of the time, and it's an unencrypted channel. So it just, anybody can go out there and say hi, or is my radio working, and you'll get some responses, right? When you want to create your own channel, you just create a channel, and creates the encryption key, and then somebody can scan the QR code and add that channel to their radio, and then they become part of that group chat. Think of that as an encrypted group chat channel, right? That's basically what that is, right? So you can have as many of those, I think up to 10 on the current software, but you can have a bunch of those for different purposes, and they can come and go at will. The other nodes will forward those packets if they're encrypted, but won't be able to read them, right? So the network, the mesh network as a whole still supports you, right? Even though you're doing private communications. It has the capability to do direct messages. Basically, a public-private key pair is created and an AES key is shared. So you can do message to one specific node if you want to. That's another way of using this, right? If you just want to talk to specific people. I do note, back up your public and private keys, because when you reinstall the software at some point, you still want to become yourself, and so you want to reload those keys so other people can recognize you. Otherwise, they have to clear their database and say, oh yeah, I trust that key again for that user. So now we're going to move a little bit into what does it mean to be, how do you set these up if you want to be a covert client, right? And there's a bunch of stuff involved with this. It's not really hard. These are all configuration options. You don't have to do much. So the first thing you probably want to do is create a secure channel, right? Make that private channel that you want. You'll have an encryption key. And you probably want to remove long fast. And the reason I say remove long fast, you can change it now, but the default channel is long fast, and all of your system messages and all of your positional messages all go to the default channel. So your node is not just sending typically is not just sending your traffic, it's also saying, hey, I'm this node, and here's my name, and here's my information, and here's my neighbors, and it's trying to do other things that are useful for the network as a whole. And if you have a GPS, it can send your GPS coordinates at some regular frequency, right? So you may want to, remove the long fast channel altogether and use your encrypted channel, because then if it gets sent on the encrypted channel, it doesn't matter. That's still useful for your group, but doesn't get sent to anybody else. There's a thing called a role in the configuration, and by default, you're in the client mode, right? And the client mode will forward other people's traffic and let you send your own, right? You're a normal client. I'm going to suggest you put it into client hidden mode. And that does two things for you. First of all, it turns off all those other system messages that you might have been sending. It also tells your node to stop forwarding other traffic. It's only going to send traffic when you send a message. And the advantage of that is that means your node is not out there pinging regularly as other people are sending traffic. And if I'm worried about somebody doing direction locating, right, I want my node to be transmitting as little as possible, right? So client hidden is going to turn your node into a device that only sends when you want it to send. It will receive everything it gets, right? So that part doesn't change at all. Receiving is nice and passive, we don't care, right? But limit the amount of stuff you send. You've got a hop count. Right, so the hop count in Meshtastic can go up to 7. The protocol only says 7, so don't expect it to cross the whole country. It won't. Right, 7 is the maximum you can set it. But make a decision as to how far you need your traffic to go. Right, no reason to send it. We're going to minimize the blast radius. We're going to do the best defense we can. Keep your traffic down to the lowest number of hops that meet your needs. There's an option for controlling rebroadcast. Doesn't matter if when you're in client hidden mode, because you're not rebroadcasting traffic anyway, but we'll talk about that in a second for the other ones here. You may or may not want your position to be on. So first of all, you can fake your position, right? You can tell it, use this GPS coordinate, don't use, even if my device has a GPS built in, I can say, don't use that, use a fixed coordinate, right? So my home node is not actually located at my house, it's offset by some distance. But it's close enough that if somebody's looking at it and wants to know where I am, they're gonna get the right ballpark, right? But if you have a group of people and you care to track where they are, right, then having position updates can be a useful feature, right? So you're going to decide whether or not that's useful in your particular application to know where individuals are. There's a heartbeat option you can turn off. That's just blinking lights. The modem preset, like I said, really controls your options of speed, reliability, and distance, right? Because you can't do all those things at the same time on a radio, right? You can't be fast and long and secure and reliable all at the same time. So you can choose those if you change those if you need to. But again, long fast tends to work pretty well, and it's the one that most nodes are listening to. Realize if you change off of long fast, that means there's a lot less people that can forward your traffic, right? So keep that in mind, right? Consider a standalone device, right? Again, if you don't want to carry your cell phone with you, this lets you have that communication capability without having a cell phone, right? Put a PIN code on it, right? If it does fall into the wrong hands, let's not have it be a wide open device, right? So what does this do for you? If you went through that whole checklist that I just gave you, right, what does this do for you? Well, again, your node receives everything. Your node only transmits when you want to send data, so you're not transmitting more often than you need to. It's generally a low power, shared frequency. The 915 megahertz stuff is shared with a lot of devices, so your signal is hidden within the noise in general. Again, you can decide whether or not you're going to send position, depending on whether or not you need to know where your team members are for that channel, right? And the one thing to realize here is if your client falls into the wrong hands and your public key falls into the wrong hands, there's no forward security involved in this. If they've captured the existing encrypted traffic, they could then use the key to decrypt it, right? So you do care about protecting the device and not letting the AES key fall into the wrong hands, right? Because it is just an AES key, and they could have recorded the traffic without being able to decrypt it and then later decrypt it at a later time. Right. So, but reasonably good. I mean, in terms of everything else you're talking about, it's still a pretty darn good mechanism here for talking within an area. So you can't. It's a radio broadcast. It's gone out to other people. There's no central server that could delete the messages and then not have available. If somebody's already recorded them, they've already recorded them. So far, I don't think the software has the ability to delete it off of your device, right? So the question was, what about deleting them off the device or having time-limited messages that could disappear after a certain period of time, right? So today, I don't think the software supports that. Again, it's open source software, so it's a good concept, right? We'll talk a little bit more of some of the limitations, but that actually ought to be added to my limitations screen because I didn't have that one. Now, I want to point out another interesting benefit of the fact that this is a really expensive device. Because these are really inexpensive devices, there is nothing stopping you from deploying a Gorilla node somewhere where you need it, right? Put a box up that looks legitimate, has an antenna sticking out of it, has a solar panel on it maybe, or battery powered, whatever. These are disposable at 20 bucks, right? At 20 bucks, I can drop this on the top of a parking garage with an 18650 cell in it and have a radio node that's available for the next day, right? And now I get 2 kilometers or 6 kilometers or whatever out of that from that location, right? So if I need to coordinate an activity in a particular region where there isn't enough Meshtastic traffic, or where I want to add capabilities, right? Or I want to know that there's a good capability between my team of people, right? These are cheap enough nodes to drop anywhere you want. And if you put it in a nice box, unlikely anyone is ever going to take it down, right? No one bothers. They assume it's somebody else's problem and leave it there. There are also some cases that people have made that look like just lights, like solar-powered lights and have the radio built into them, right? So there's some interesting options there as well, right? So you can deploy to Gorilla nodes. That's what I mean by a covert relay, right? We can put these out in a location where we need it, right? Now this configuration is a little different. It's pretty close, right? Again, it can have an 18650 cell, last for about a day. It can have a solar panel if you want it to run for a longer period of time. In this case, when you're doing a covert node, don't bother to put the security key on the channel, right? Because the nodes will forward the traffic whether or not they know how to decrypt it. So your node can be out there and not have any ability and not have the ability to read the traffic that's going across your channel. You're probably going to put the node in client mode, right? That's the most useful relay. for everybody. There are a couple nodes I will mention. There are a couple modes that you can put it in. There's a router mode and a repeater mode. Don't use those unless you really know what you're doing. It sounds tempting to say I'm a repeater node or whatever, but it turns out that that changes the algorithm of how it forwards packets. And you become a priority for forwarding packets. So if you're not really well located and really correct, you'll do more damage to the mesh than you'll get out of doing it. You probably just want to be a client, right?